Welcome to the viewers. Now we discuss Taylor's theorem in complex analysis. First we are going to discuss the statements of the theorem. Let us consider phi z be analytic in a domain, arbitrary domain, that is a D suppose, and then phi z can be expressed in NBD of some NBD we consider here, like L is such that mod of z minus z0, that is less than some constant like k of arbitrary point like z0 if in B D, then it can be and expressed in the form of a power series that is power series of phi of z that can be sum of, that is n equals to 0 to up to infinity, a n into z minus z0 whole to the power n. We are taking in this form of power series, taking it equation number 1, and which converges in the disk L, where this K is the shortest distance SD between Z0 and boundary of D. This is our statement and criteria. You have to prove this result of the power series. Now let's discuss how to prove. Let's watch. For the part of proof, let us consider a circle, if we say as omega, such that mod of z minus z0 is equals to rho. For 0 less than rho, if we say, it will be less than k, and eta be any point, any arbitrary point in the interior of the circle, then by Cauchy's integral formula, that is phi of eta, that will be 1 by twice pi I integral contour of the curve omega, if we consider this curve omega, that is phi of z minus eta dz, taking it equation number 2. And now 1 by z minus eta can be written as 1 by z minus eta equals to 1 by z minus z0 minus eta minus z0, and that will be 1 by z minus z0, and if we take it as 1 minus eta minus z0 by z minus z0 whole to the power minus 1, and if we expand it, z minus z0 1 plus, just for the expansion, eta minus z0 by z minus z0 plus eta minus z0 by z minus z0 whole square. In this way we approach it. Now by using the property of ratio test, we have mod of eta minus z0 by z minus z0 always less than 1, and inserting this expression for 1 by z minus eta in equation 2. Then we have phi of eta is equal to 1 by twice pi I contour over omega, the curve 1 by z minus z0, and within the bracket phi z plus eta minus z0 by z minus z0 pi z plus eta minus z0 by z minus z0 whole square pi z plus, in this way, up to dz. And certainly this will be 1 by twice pi I contour over omega, summation n equals to 0 to up to infinity phi z by z minus z0 whole to the power n plus 1. It is clear that from these two product n plus 1 highest power, and if summation n equals to 0 to up to infinity eta minus z0 whole to the power n dz, we put in this format. And now we have considered these expressions, and now proceeding, let's watch what happens. And but we have mod of phi z eta minus z0 whole to the power n by z minus z0 whole to the power n plus 1, that will be less than equals to some constant, if we consider as n rho by rho into mod of eta minus z0 by rho whole to the power n, and where n rho, that will be maximum of value. This z is belonging to the curve omega, mod of phi z in these areas. And if we consider actually this type of curves, and for the better considerations, if we say this is a particular type of domain, and if we consider in this domain, and this is a domain D actually, and if we consider a circle, and this circle of radius Suddenly the radius k, if we consider, just draw a figure, rough figure, actually not exactly, and if we consider any point say z0, and if we consider the circle like k, and if another circle here we consider like the shape, and if this type of distance is called radius is called rho, and arbitrary any point say eta, suppose lying this is called eta. So in this rough figure we are considering these areas and this type of a rho region, and that certainly it will be less than of k, total value is k here, total radius, and this is for radius rho, and this is any arbitrary point say eta. In this way we draw this figure. And now we are considering this type of region, and as we know, mod of eta minus z0, there is the difference, eta minus z0 by rho, that will be certainly less than 1, and the geometric series summation this n equals to 0 to up to infinity mod of eta minus z0 by rho, that whole to the power n converges, as it is GP series, that converges, and hence we can say the integral phi of eta, that will be 1 by twice pi I integral over gamma, that we write previously and already write, sum of n equals to 0 to up to infinity phi z by z minus z0 whole to the power n plus 1 eta minus z0 whole square whole to the power n dz. This results and converges, which also converges, and that converges uniformly on the curve omega, if we consider this type of result. And moreover, this is a continuous, so piecewise, and since this is continuous, and so term wise integration is permissible, so phi of eta summation n equals to 0 to up to infinity eta minus z0 whole to the power n by twice pi I integration over the curve omega, that is phi of z dz by z minus z0 whole to the power n plus 1, and that will be sum of n equals to 0 to up to infinity eta minus z0 whole to the power n by, this is a Cauchy integral formula we can apply, so it will be pi n z by in factorial, and certainly it will be sum of 0 to up to infinity a n eta minus z0 whole to the power n, where this a n will be phi of n z0 by n factorial. And now, since eta is arbitrary in L, so this Taylor series expansion is valid for all eta in L. Hence we prove this result. We end our discussions today. If you like this video, like it, share it, and don't forget to subscribe the channel. Thanks for watching.